Let's begin. Today's May 28th, 2024, and we're doing the Daily Turing Machine Puzzle. Today's puzzle uses 6 criteria cards and its 6 verification cards. Let's go to turingmachine.info for the details. So the 6 criteria cards that are used for today's puzzle are 2, 6, 10, 16, 20, and 22. And we're using the purple verification cards. And above you'll find the unique identifier for today's puzzle that you can always go into turingmachine.info and look up its details. Let's go solve. So in our grid above, we've got our 6 criteria cards. On the top row, we've got criteria card A, criteria card B, criteria card C, and in the bottom row, we've got criteria cards D, criteria cards E, and finally criteria card F. If you look at criteria card A, this card will look at the first digit, the triangle digit, and compare that value to the number 3. So should the triangle value be less than 3, equal to 3, or greater than 3? Criteria card B looks at the middle digit, the square digit, and will let us know whether that value should be an even or an odd. Criteria card C will look at the 3-digit code and let us know how many 4s are in our solution. Should there be no 4s, 1, 2, or could they all possibly be 4? Criteria card D, again, looks at the 3-digit code and will let us know if there are more even than odds. Should there be more even than odds, or vice versa, less even than odds? Again, if you look at the 3-digit code, criteria card E will let us know whether there should be no repetitions among the 3 digits, as in the example 1, 2, 5. Could there be a duplicate or a double number in our solution, as in the example 1, 1, 2? Or potentially, could there just be a single digit repeated 3 times, as in the example 2, 2, 2? And finally, criteria card F looks at the 3-digit code and will let us know if there's any order to the digits. Could they all be ascending, slowly increasing, as in the example 1, 3, 5? Or vice versa, are they descending, getting smaller, as in the example 4, 2, 1? Or potentially there is no order to the digits, as in the example 2, 3, 1, since it starts at 2, goes up to 3, and then comes down to 1. So remember, our objective is to find a unique 3-digit code that meets all of the criteria that we just described. And we're going to start off with our proposal of 314. So the first thing I want to test is criteria card B and find out if that middle digit is an even or an odd. Okay, so the Turing machine responds that it does not approve of my choice. If you look back at my proposal of 314, that middle digit, the square digit, is an odd. So the Turing machine is telling me, no, it does not approve of my odd value. Therefore, square must be an even digit. So I'm going to write that down in my notes in section B. That square is an even digit. Okay, and so that means that I'm going to come up above and cross out all of the odds, since they no longer qualify for that particular criteria. Okay, so next, since I do have a single even so far, I want to test, or I want to find out if there are more even than odds. So I'm going to choose criteria card D. Okay, so the Turing machine approves of my proposal. Notice that in the example that I have 314, I've got 2 odds to 1 even. And so it approves of that. So it's telling me that yes, there are more odds than evens. So in my notes for section D, I'm going to say odd, or I'm going to put even is less than odd, which means that, of course, there are more odds. So specifically then, notice that since my square is even, that means that both triangle and circle are odd. So that's what I'm going to write down. I'm going to say triangle and circle are odd. Okay, so that means that in general the structure of my solution is going to be odd, even, odd. Okay, fantastic. So that didn't really help us eliminate. Actually, no, I take that back. Since I know that it's odd, even, odd, that means I can cross out all the evens in both triangle and circle. Okay. All right. So let's see, what else can we test? Since we do have a single even, criteria card C will let us know, right? Obviously at this point, all three digits cannot be 4. We can't even have 2 4s since we know that there's only one even. And so therefore, either the 4 is present or not. So at least that'll give us an idea of what that even is. So let me think about that. So I know I could always do that. Maybe I should test something else. For example, is there a duplicate? If there's not a duplicate, then I know, 1, 3, or 5, one of those has to be in triangle and circle with no repetition. Would that be more beneficial? Because I could always test the 4, it's a 50-50. And of course there can't be a triple digit because we have odd, even, odd. Well, that's also a 50-50. Then perhaps maybe I have triangle equal to 3. So is there anything else? And then there's the ordering. So I'm going to test whether there should be a double or not. We already know, again, can't be a triple, so it's either a double or not. So yeah, let me go ahead and test criteria card E and see if there's a double. Okay, so if you look back at my initial proposal of 3, 1, 4, they are all distinct. So that means there are no repetitions. So let me write that down for my notes in E. So there are no repetitions. Okay. Well, that does it for this turn. I've already done my 3 tests for the turn. Now I'm going into trying to construct my second proposal. So again, since there are no repetitions, I know that there's no one for triangle or 1 for circle. It's got to be they got to be distinct essentially. Okay, so somehow notice that again we don't have anything that indicates purple, what purple could be. So that means it's going to be forced into something, and more than likely the forcing will be in whether there's some sort of order or not. So how could I construct my proposal so that there's some sort of, so that circle is somehow forced into something else? So it could be that it's descending, and it could be 3, 2, 1. That's a possibility. Or even 1, 2, 3 for ascending. But similarly, 3, 4, 5 would work, and 5, 4, 3. So let's see. So even if you had, say, ascending or descending, I guess the square could sort of dictate which descending it would be, or which ascending it would be. So that's a possibility. Could it be that it's somehow mixed? Yeah, I suppose you could say 1, 4, 3 is no order. Or 3, 4, 1 for no order. So yeah, so it seems like we've got a lot of possibilities for the ordering that would force circle to become, that particular value. So in that case, I think I'm going to test 3, 4, 1 and predict that there's going to be no order. So let's go ahead and do that. So I'm going to try 3, 4, 1 and see where that takes us. Okay, so the first thing I think I'd like to figure out is whether there is order or no order. So let me go ahead and test criteria card F. Okay, so the Turing machine approves that there should be no order. So I'm going to write that down in my notes. So there is no order. Okay, so that doesn't necessarily disqualify any numbers. So now let's test whether there's a 4 or not. So that's criteria card C. Okay, so there is a 4. So I know that middle digit is definitely a 4. So in my notes for section C, I'll say there is a single 4. And since we know square is the even digit, let me go ahead and cross out the 2. And so we know there's a 4. All right, so now that we know that there's no order and no duplicates, can we somehow list out the values and sort of maybe deduce what triangle should be? So if I have a 4, I don't think it's going to be a 5, because 5, 4, 5 doesn't work because there's no duplicate, and then 5, 4, either 3 or 1 would be descending. So I know that it can't be a 5 for triangle. Okay, so what about if it's 3, it would be 3, 4 with no order. It wouldn't be 3, 4, 5. It wouldn't be 3, 4, 3 because there's no duplicate. So it would have to be 3, 4, 1, and that's what I have so far in my proposal. And so obviously, since I have it in my proposal, I won't write it out, but that would be it. What about if it's a 1? It would be 1, 4. It wouldn't be 1, 4, 5 because that would be ascending. The only other possibility would be 1, 4, 3. And so at that point, yeah, there's no way to really verify whether it's the 3, 4, 1 or 1, 4, 3. So basically, I do have to test A. And so, okay, so it was 3, 4, 1. So let's go ahead and say that the Turing machine approved of my triangle digit being 3. So I'll just write down triangle is equal to 3. Okay, so let me go ahead and cross out the 1, since we know for sure that triangle is not 1. And because there's no duplicate, obviously circle can't be 1. And, whoa, hold on. Oh, I apologize. No, there would be no duplicate there. So it wouldn't be a 3. That would be the duplicate. And of course it can't be 5 because that would be ascending, and we know that there's no order, so it's not a 5. And so yeah, so the solution would be 3, 4, 1. Okay, so I filled out all my notes here. Everything looks in order. So let's go ahead and go to turingmachine.info and verify the solution. So 3, 4, 1, and if I click verify, okay, yes, we got it. So now let's go see if we beat the Turing machine. So the good thing is we did do it in 6 tests, which equate to the 6 verification cards. That's always a good indication that we'll score well. So in the first turn we got B, D, E, and only B was incorrect, and then in the second turn we did all the other tests. So let's do B, D, E in the first turn. B, D, E, and then again in the second turn we did everything else and we got it correct. So let's see, how did we do versus the machine? Okay, so we tied, so it was 6 questions each. So, but anytime we tie the Turing machine, that's technically a win. So, so we did good. If you enjoyed this solution and puzzle, please make sure to give it a thumbs up. If you saw that I made a mistake or maybe I said something wrong, please share and write it down in a comment. And if you want to be notified of the next video, make sure to subscribe and you'll be notified. Well, until the next time, have a great one.